Okay, welcome to our video for 11.2. We are rationalizing denominators in this concept. So first and foremost, before I jump right into some examples, I'm going to talk for a second about exactly what rationalizing the denominator is. So bear with me for a second while I kind of explain. If you flip your notes over to the ones from the day before, and on this copy it's blank, but the copy I kept from our class, if you look, we did some multiplication and division with radicals. So when we got down to the level 5 and 6 problems, they were division problems. Now, in these specific problems, and I did this on purpose, in these specific problems, in the denominator, we had perfect squares. So we all knew the square root of 16 is 4. Again, 4. Again, 4. I guess I liked 16 on this specific day. Square root of 25 is 5. Over here, to the right, square root of 25 is 5, and then we multiplied it by the 3 coefficient on the outside. 36, we got 6, 4, we got 2, 16, we got 4. So for this specific day of notes, everything worked out nicely because intentionally, I did this on purpose, all the denominators had perfect squares, meaning that the radical went away. All right, so that brings me to, I guess, one of the big rules with radicals. There can never, ever, 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 a million times, ever, ever, ever be a radical in the denominator. Okay? So the reason why we didn't have a problem and we didn't have to do this rationalizing in the other day of notes is because, like I just said, I specifically made it so that we wouldn't have radicals in the denominator because they were perfect squares. It took care of itself. However, today in these notes, what we're doing is we're looking at ones that don't have perfect square numbers in the denominator. So if you look, for example, this is the square root of 5. That's not a perfect square. Square root of 2, square root of 2, square root of 3, square root of 5, square root of 3. Okay, hopefully you're getting the idea here. So this becomes a problem because, like I just said, there can never be a radical in the denominator. So in order to take care of that problem, we have to do something called rationalizing the denominator. So, all right, what does that mean exactly? How do we do that? Well, basically, this means that you're going to take whatever is in the denominator, whatever radical, I should say, is in the denominator, and you're going to multiply that radical into the top and into the bottom of the fraction that's already there. So let me fill this in here. We multiply the top and bottom by the radical from the denominator. Okay, abbreviated denominator. All right, so let me show you what I mean by this. Number 45. Like I just said, we cannot have a radical in the denominator. And in number 45, the radical that is down there is radical 5 or square root of 5. So in order to get rid of that, what we're going to do is we're going to take that radical and we're going to multiply it to the top and to the bottom of this fraction. So it is radical 5 to the top, and then again to the bottom, radical 5. Okay? And then it's just the multiplication properties that we learned the other day, which is coefficients get multiplied together and radicands get multiplied together. You can't crisscross the two. So we have 2 radicands. 3 times 5 gives me 15. Okay? And in the bottom, 5 times 5, radical 25. All right, and then at this point, we can just go ahead and solve or simplify. In the top, if I try to simplify 15 and do a factor tree, I just get 3 and 5, and I don't get any groups of 2. So there's nothing I can do to the top. But in the bottom, what is the square root of 25? 5. And as long as you have an answer that doesn't have a radical in the denominator, you're done. Okay? All right, 46, same idea. In the denominator, we have the square root of 2, and that is not okay. So we're going to take the square root of 2, and we're going to multiply it to the top and to the bottom. Wow, my pens are like running out of ink. I don't like this. Excuse me while I switch. All right. So then once we do that, we can just go ahead and multiply inside of the radicals, radicands with radicands, coefficients with coefficients. So 5 times 2 gives me radical 10. And in the bottom, 2 times 2, radical 4. So at this point, you want to simplify your answer. In the top, if I do a factor tree with 10, I get 2 and 5. No pairs, so that doesn't do me any good. Radical 10 is going to stay. But in the bottom, the square root of 4 is 2. 47. We have 3 over radical 2, so we're going to multiply that radical 2 to the top and to the bottom. In the top, however, this time we have a coefficient. 3 is not inside of a radical, so it's not a radicand. This 2, however, is a radicand, so they can't go together. You're going to just have to leave them separate. Just 3 radical 2. Okay? In the bottom, 2 times 2 gives me radical 4. So before I circle this as my final answer, I need to make sure I can't simplify. In the top, we have radical 2. That's a prime number. You can't factor tree with that. However, in the bottom, square root of 4 is 2, so we're going to change that denominator to 2. No radicals in the bottom. Perfect. All right. 48 I will do, and then you will do 49 and 50 and pause the video, okay? So denominator is radical 3. You multiply it to the top and to the bottom. Radicands can go together. 4 times 3 gives me 12. And in the bottom, 3 times 3 gives me 9. So now I'm going to simplify. I can do a factor tree with 12. Let's see. 2 and 6. 2 and 3. It's okay if your factor trees go off sideways like this. It's no problem at all. So who gets to leave? Any pair of 2 numbers. So I have 2 2s here. So that means 2s are going to go to the outside of the house, or the radical, I guess you could call it. And then stuck at home is the loner 3. Now in the bottom, what is the square root of 9? All done. Okay? So in this chapter, just make sure, or not this chapter, this section, make sure that you deal with the numerator and the denominator separately. Like the square root of 12, break that down to prime factors, factor tree with that first, and then take care of the denominator separately, okay? So I want you to go ahead and do 49, 50, pause the video, and when you're done, resume and check your answers. So here are your answers for 49 and 50. In number 49, did you remember to do a factor tree on radical 20? If not, you need to fix that and make sure you pay better attention next time. On number 50, with 15, if you do a factor tree, it's just 3 and 5, no pairs. That's why radical 15 did not get simplified. All right. Okay, so hopefully by now you've gotten it. The first 6 up here were just numeric, and now we're going to the bottom where we're going to throw in some variables, okay? So one thing that I want you to remember about the previous day when we did multiplication and division is that coefficients can be multiplied with other coefficients. Well, they can also be reduced or divided, I guess you would call it, with other coefficients. All right, same rules apply for multiplication and division. Same thing with radicands. Radicands get multiplied with other radicands, like we did up here, 3 times 5, and we got 15. But they can also be divided or reduced as long as they're both radicands, or basically a radicand, you know, is whatever's inside of the radical. All right, so let me show you what I mean by this. Number 51. These are both inside of a radical. Okay, so they are both radicands. So before we even go ahead and rationalize the denominator, I'm going to reduce, okay? Because what that's going to do is just kind of make my life a little bit easier. It's going to get rid of one of these variables. We'll talk about that in a second. And then it's less I have to worry about. So let me show you what I mean. Right now, inside of a radical, we have m and m squared. So over here off to the side, if we just were to imagine for a second that they weren't in radicals, we'd have m over m squared. Well, in the past, in chapter 7, when we had something like this, we would subtract the exponents and then put the answer where the bigger exponent was. So this would be 2 minus 1, which is 1, and then the answer would go down to the bottom because that's where the bigger exponent is. Well, you could do the same thing here because, like I said, they're both inside of a radical, so they can kind of go together. So what this is going to become is just radical 3 over radical 5m. And how I got that is 2 minus 1 is 1, and leave your answer where the bigger one is, which is in the bottom. Remember doing that? Okay, so now I can go ahead and rationalize the denominator. So I'm going to take the radical from the bottom, multiply it into the top and to the bottom. So 3 times 5 is 15, and don't forget about the m. And in the bottom now, I have 5 times 5, which is 25, and m times m, which is m squared, okay? So now I'm going to simplify where and when and if I can anywhere. In the numerator, radical 15, we already did that over here, remember? It's only 5 and 3, I have no pairs. So you can't simplify the numerator. That's just as good as it's going to get. But in the denominator, we know that the square root of 25 is 5, and then m squared, remember, is like m times m, and you can take things outside of the radical as long as they are in pairs. So we can also take out a 5, I'm sorry, not a 5, an m. So we're going to have just 5 and m on the outside of this radical with nobody left at home. So this becomes 15m inside of a radical over 5m. And you can't reduce those now because 5m is a coefficient, and in the top it's a radicand. All right, 52. Again, look, I want you to notice, we have v cubed and v cubed. They're the same thing, they're completely identical, and once more, they're inside of the radical. So that means that I can reduce here. So if I'm going to reduce, they're just going to cancel. That's like x over x, 5 over 5. They're gone, okay? So now all I have is radical 3 over radical 5, and there's no variable, so you should be able to handle this one. I want you to go ahead and finish this one. I'm going to skip for now. All right. And you know what? In fact, I think it is exactly like, actually, it's not exactly like, yes, it is. It's exactly like 45. I lied. Radical 3 over 5, radical 3 over radical 5. Okay, so to solve 52, just look up at 45. All right, 53, I'm running out of space here. We are going to reduce it first. Again, inside of the radical, we have b cubed and b to the 4th. So we are going to subtract, and we have 2. Remember, no b's left because 4 minus 3 is 1, and the answer stays in the bottom because that's where the bigger exponent is. So on top, all we have is just radical 2 over radical 3b. Okay? Now take that radical from the denominator, rationalize. Okay? So then this becomes 2 times 3b is 6b. And in the bottom, 3 times 3 is 9, b times b is b squared. So we have 9b squared. All right. And just like before, b squared is b times b. And remember, when we have groups of 2 of anything, it gets to come to the front of the house. They get to leave. Remember, we talked about being teenagers. And 9, the square root of 9 is 3. So 3 and b both leave the house, and nobody's left at home. So in the bottom, it's just 3b, and in the top, radical 6b. Why didn't I simplify the top? Because if I do a factor tree with 6, it's just 2 and 3, and there's no pairs. All right, so this is it for that one. All right, before I forget, because I'm running kind of long on this video, so I'm going to be stopping soon, I want you guys to go ahead and cross off 58, 59, and 60. I had students that were in class on this day cross off those same 3 ones at the bottom because they're a little more complex, and I've decided that we're not going to get this far into it, but maybe I'll throw something extra credit like this on your test. So definitely try them, and if you want me to look at them in class, let me know, and I can let you know if you're on the right track. But the rest of these, we have 54, 55, 56, and 57. So I have 4 more. So here's the deal I'm going to make with you. I will do 2. I guess I'll do these 2 even ones over here because I have more space. And then I want you to do 55 and 57. And if you're out of space like I am, you have a couple options. We crossed off stuff down here so you can move them down in this area. Or the back of your paper is blank. You can do them back there as well. Okay, so let's go on over here to 54. Okay, so we're going to reduce first because, again, just like with everything else that we've done so far, they are both inside of the radical, so we can reduce those. This becomes radical 3, I don't know, variables. We have 4 minus 2 is 2. Leave the answer in the top because that's where the bigger one is. And in the bottom, all that's left is just the radical 5. So we're going to take that radical from the denominator, rationalize, so that means multiply it to the top and the bottom. And now this is radical 15n squared over radical 25. Okay, almost done. Now, in the numerator, we already talked about how square root of 5, we already talked about how the square root of 15 doesn't work with a factored tree because 3 and 5, there's no pairs. However, this n squared right here, that's n times n. And remember, things can leave the house as long as they're in pairs. So that means a pair of n's, so 1n, is going to go outside of this radical. So n, but 15's got to stay home because there's no pairs. Over square root of 25, which is 5. All right, one more. 56. We're going to reduce first. If you don't see an exponent, it is 1. Remember we talked about that. So 2 minus 1 is 1. And you'll leave the answer in the top because that's where the bigger one is. So the top now becomes 3n and the bottom becomes just square root of 2. So we're going to take the bottom, multiply it to the top and to the bottom. That's called rationalizing. Let's go down here with this because I'm running out of space. 3n times 2 is 6n. And then in the bottom, radical 4. Now let's see, I can simplify the bottom but not the top because 2 and 3, no pairs. All right, so this is going to stay radical 6n, and in the bottom, the square root of 4 is 2. All right, so I left you 55 and 57. Go ahead and try them. I'm not going to post the answers on this video, but if you want to bring them to class, I can look over them for you if you'd like. And then also, these 3 are crossed off if you want to give them a go. I can also look at those also and let you know if you are on the right track, all right? Okay, and make sure you study and you know how to do rationalizing because it will be on your quiz. All right, have a good night.